Hi, do you know how to write the ionic formulas for the following compounds? No? No worries, join my class. Hi everyone, welcome to my channel. Today we are going to have two objectives. We are going to practice how to name cations, anions, and ionic formulas, and then we're going to practice how to write ionic formulas. Please don't forget to answer the questions at the end of the video. If you have any questions, please don't hesitate to share it with me in the comment section, and let's start. To name ionic compounds, we should practice naming ions first. Ions are of two types. We have simple ions, which are cations and anions, and we have polyatomic ions. To watch our previous video for simple ions, I will keep a link for it in the description. Now, cations, usually they share the same name as their parent atoms, as you can see here regarding sodium and aluminum ions. While for the anions, usually the name of the anion ends with IDE, like here oxide, fluoride, and sulfide. Now regarding some ions that have more than one possible charge like copper, iron, gold, silver, all these ions, we should specify the charge in their name using a Roman number. Like here, the first ion for copper with a positive 1 charge, we are going to call it copper 1 ion using a Roman number. And the second one, which has a positive 2 charge, we are going to call it copper 2 ion. The same thing is happening with iron. We have two possible charges. We have 2 plus, we are going to call it iron 2, and we have 3 plus, we're going to call it iron 3. So whenever we have an ion with more than one possible charge, we have to mention that charge in their name, like iron and copper, using a Roman number. That was about simple ions, but what about polyatomic ions? Polyatomic ions are ions that are made of more than one atom. Like here, ammonium is made up of 1 nitrogen atom and 4 hydrogen atoms with a positive 1. This positive charge is for the whole structure, not for hydrogen only. And also carbonate ion, it's made up of 1 carbon atom and 3 oxygen atoms with a negative 2 charge, and this charge for the whole structure. I have summarized for you some of the polyatomic ions. These are the most frequent ones. For sure there are more than these if you find them online, but I think if you memorize these, they are more than enough. You can pause the video and try to copy them because we're going to practice them while we are naming and writing ionic formulas or ionic structures. Now let's start with naming ionic compounds. Ionic compounds are made up of two parts. The first part, which is the positive part, the cation, and the negative part is the second part. So we start by naming the cation first, or the positive, and then we name the second part, which is the negative. As we learned before, that the positive part, it has the same like its parent name. The second part should end with IDE if it is a simple ion. Like here, we start with the first part, which is sodium, and then Cl, it's the anion, so it is called chloride. So sodium chloride, it's the name of this structure. Here is another example, KHCO3. The first part is the cation, while the second part is the anion. To name the first part, it's easy, it's potassium, while the second part, it's a polyatomic ion. We can find its name from the table that I gave you from a while, which is bicarbonate. So the name is going to be potassium bicarbonate. One thing you should keep in mind that when we name ionic compounds, just name the first part and the second part, regardless of the subscripts. Like here we have the first part is Al and the second part is S. So when we name this ionic formula, we just name it aluminum sulfide, regardless of the subscripts. We don't count the 2 and the 3. Another example, CaF2, we call it calcium fluoride. We don't say calcium difluoride. We don't count the subscripts. Before moving to writing ionic formulas, there is one thing which is very important. When we have ions that have more than one possible charge, like here CuO and Cu2O, we should find the charge for copper in both cases before we name the ionic formula. Like in the first case, we know that the charge for oxygen is -2, so the charge for copper is +2 to balance that. Then the name is going to be copper 2 oxide. While in the second case, we have 2 atoms of copper to balance the -2 charge of oxygen, so each one of them is going to have a +1 charge. Then we're going to call it copper 1 oxide since the charge is +1. And as you notice that we name the copper ion according to its charge, not according to its subscript. In the first case we have 1 as a subscript, but we called it copper 2 oxide since the charge was +2. In the second one we have 2 subscript, but we called it 1 since the charge was +1. So don't forget, when we have ions like this, we name them according to their charge, not according to the subscript like most of the students they do. The second part is talking about writing ionic formulas. To write the formula of ionic compounds, we should start by writing the cation and the anion, and then we try to balance their charge by multiplying them with the proper numbers, so the positive charge is going to cancel the negative charge. Like here, if you want to write the formula for sodium fluoride, I will start with writing the formula for sodium ion, which is Na+, and fluoride, which is F-1. As we can see that the charges are balanced, so there is no need for me to multiply, and the formula is going to be NaF. Another example, calcium chloride. Calcium is Ca2+, while chloride is Cl-. To balance the positive charge, we have to multiply the chloride ion by 2, or we simply swap the charges without their signs. So multiply the calcium by 1 and the chloride by 2, and we get the formula for calcium chloride, CaCl2. By the way, the method of swapping the charges without their signs, it's called crisscross method to write the ionic formulas. A third example, magnesium oxide. Magnesium is Mg2+, oxide is O2-. As we can see here, we have 2- and 2+, they balance each other, so there is no need to multiply. We just write the formula MgO without multiplying. With the same procedure, we write the formula for aluminum oxide. Aluminum is Al3+, while oxide is O2-. We just swap the numbers without their charges. The formula is going to be Al2O3. Let's see how to write ionic formulas when we have polyatomic ions. Like here we have calcium nitrate. Calcium is Ca2+, and nitrate, we can check it in the table that I gave you from a while. It is NO3-. So we write the formulas for calcium and nitrate, and then we swap the charges without their signs. Here we have to keep in mind that when we multiply a polyatomic ion with a number, we should put it in a parentheses, and the formula is going to be CaNO3 in a bracket multiplied by 2. Another example with polyatomic ion, magnesium sulfate. Magnesium is Mg2+, sulfate, we have to check the table of the polyatomic ions. It is SO4 2-. Then we write the two ions, we swap the charges without their signs. As we can see here, we have both charges are the same, so no need to multiply, and the formula is going to be MgSO4. A third example with polyatomic ion, copper 2 hydroxide. Copper 2, it means that copper with a charge 2+. Hydroxide, we have to look at the polyatomic ions table. It's OH-. We write the two ions, we swap the charges, then the formula is going to be CuOH2. Keep in mind that since OH it's a polyatomic ion, to multiply it by 2, it should be in a parentheses. Since if you multiply it by 2 without the parentheses, it means that the 2 is going to be only for the hydrogen, while this is not true. The 2 should be multiplied with both of them, the oxygen and the hydrogen. Now it's your turn to answer. Pause the video, copy the questions, answer them, put your answer in the comment section below. Thank you.